Hi everyone, thank you so much for joining my talk. This talk will be about a use case I had in one of the companies that I worked for, in which we had Airflow, which is a tool to basically run tasks. Some tasks need secrets, some don't, and we had challenges of how we provide the secrets to the Airflow jobs, how we do it in one single way, although we have different users and different clients that utilize Airflow in different ways. So this talk will be basically about that. We will cover the requirements, the solution, the whole works. So first of all, hi, my name is Hila Fish. I'm a DevOps tech lead with over 15 years of experience in the tech industry. I talk about some DevOps topics in conferences, including Terraform, and that's why I became a Hashicorp ambassador. This is the second time, and this is my second talk about a Hashicorp tool, which is Vault. I also help organize conferences in Israel, where I live. DevOps Days Tel Aviv is the biggest one. And that's it for now. Okay, so the agenda for today, we will talk about the problems with secrets management that we had and usages, the solution that met our needs, and what did we achieve, aka we had, not aka, but spoiler, we had success, but in several aspects. And just some disclaimer here, I'm using a platform that just stripped down all the animations from my PowerPoint presentation. So you will see a lot of text on the slides, but bear with me and let's go over things one by one from left to right. Okay, cool. Okay, so first of all, the problems. What were the pains with secret management and usage that we experienced? So we had a general problem. We didn't have any decision or standard about secrets management. So how did it look like? We had Hashicorp Vault, and it was deployed and maintained by the SecOps team for the entire company to use. This was the intent and the overall vision. We should use it, and security team said that they are on board. They said Hashicorp Vault ticked all the boxes, licenses were purchased, and everything was good to go. But we are not using it. We had no plans to use it, no priority to set up any standards or to start using HashiCorp Vault, and overall, no shared vision with the company of having one unified tool for secrets management. And one thing that I want to cover here is that it's very important to set up standards, and not only for secrets management, but different aspects as well. Because if you don't set standards, if you don't define processes, if you keep reinventing the wheel every time a new use case arises, then you can find yourself maintaining different tools, different implementations, different platforms for the same use cases, and in the long run, it doesn't really fit the bill and it's not really viable. We also had a specific problem. No decision or standard about secrets management specifically in Airflow. So Airflow was a tool that we used widely across the department that I worked for, and it's basically a tool to manage jobs, but we used it for flows for data. And a lot of users used it, data developers, data engineers. It was widely used, but there wasn't really a standard about secrets management in Airflow. And how secrets were kept in Airflow for Airflow jobs. The default was to use the Airflow infrastructure built in connections or variables, which is not secured, and we will understand why in the next slide. And some use cases did use AWS Secrets Manager. It is secured, but it wasn't an official solution, and it was overhead to manage because some teams used it, some not. Some created the secrets manually, some created it through Terraform. So it was overhead to manage because it wasn't really organized to use it. And the thing about Airflow secrets and why it's not secured to store secrets in connection or variables is because of the meme that I created here. So basically, the meme says, you get a secret and you get their secret, and everyone has access to all secrets, meaning free love. So basically, it means that once you set up a secret in connection or variable in Airflow, it is shared amongst all Airflow jobs. So all Airflow jobs have access to all secrets that you store in connections or variables, which is a big security no-no. So free love is not always a good thing. So what do we want? Depends on who do you ask. Security says, hey, we want segregated secrets. And not only security, us DevOps team wanted it too because we are security minded. Data engineers said, we don't care what you do, just give us one easy way to get secrets, because some use connections variables, some use secrets manager, some used connection of variables, and then someone told them, no, don't use it because it's not secure. So what do? I don't know. They were very in the fog of what to use. So we just they said, let's just give us one easy way to get secrets, and that's that. And when can we have it? Once design and implementation are done. So let's cover the requirements. So high-level requirement, secrets won't be shared across all Airflow jobs. We need secrets segregation. And then, of course, we derived specific requirements as well. So left to right. Security, this is derived from the highest requirement. When an Airflow job runs, it will have access only to its needed and restricted secrets, meaning the segregation should be on Airflow job level. Tooling wise, we have Hashicorp Vault. Let's use it. So secrets should be kept in Hashicorp Vault with ownership hierarchy, which is very important to understand towards the solution that I'm gonna show here. Hierarchy means that all the folders, not really folders, in Vault you have dictionaries, and then inside you have key values, dictionaries of key values of the actual secrets. So the ownership was to have teams, and then each team have the secrets for their own team that they manage. You can swap up team with product, whatever you divide it on your end, but we had teams. So tooling was to use Hashicorp Vault, and logic, secrets retrieval mechanism should be on server side. Airflow side, server side means operators that were created for the specific solution, and then afterwards we also have the secret service that retrieved the secrets themselves, but we will cover it in a second. So the solution. We had a solution that was comprised from three components. We had Airflow secured operator, which was solely on the dev side, because in our department we had a developer team that maintained Airflow entirely by themselves. So they maintained the infrastructure and the operators. So they created the secured operator that its role is to retrieve secrets for Airflow jobs. The second component was the secret service, which is a Python service I created. So it was on the DevOps side, and its logic was to retrieve the secrets from Vault. And of course, the Hashicorp Vault was on SecOps side, but the namespace of the department that I was in was managed by the DevOps team, aka my team that I was in. So let's go over the flow of the Airflow secure operator. Again, a lot of text, I know, ignore it, and let's start from left to right, okay? So Airflow DAG. DAG is basically the job that wants to run. If it wants to, like a data engineer writes a DAG and they know that they need the secret, then they import and use a secured operator to get the DAG secret. And then we have the Airflow secured operator, which was operator that was created for this solution. It has two jobs, two purposes. One, to detect ownership tag from Airflow DAG. So if an Airflow DAG belongs to backend X team, so ownership tag is backend X. If the team was frontend Y, so the ownership tag is frontend Y. And the second role is to fetch associated secrets that it gotten from secret service. So Airflow secured operator approached DevOps secret service, which is the service that I wrote, and what it did was to, first of all, authenticate Airflow as an entity, a client that is allowed to get secrets, and then retrieve the ownership tag secrets, retrieve all the secrets that belong to backend X specifically. And then Airflow DAG can continue its operation. It gets the secrets from the secured operator, and then the DAG can use the secrets to do whatever it needs in the DAG itself. So that was the Airflow side. Secret service side. So it is a Python service that exposes an API. Its purpose is to retrieve secrets for clients. First client was Airflow, but we later on utilized it for other clients as well. The input that the service expects to have is app name and app key for a naive authentication mechanism. Later on, we wanted to tap into the regular authentication mechanism that the entire company uses for other services, but for the sake of having the service up and running, we set up this first initial naive mechanism, and then the ownership tag. And then the output is the dictionary of secrets that is basically owned by that ownership tag. So again, same as we cover the flow from Airflow side, let's cover the flow on the secret service side specifically, left to right. So step one is the authentication handler. Authenticate the client via app name and app key that it provides to make sure this client is allowed to get secrets. Step two, get Teams Vault creds. Basically, use the ownership tag to get relevant Teams Vault creds. So let's say Airflow said, get me the secrets of backend X. So I got ownership tag backend X. I now go to in secret service, in the flow, in the logic, I go to Vault, fetch the backend X app role ID and secret. So we had basically a dictionary that was managed by the DevOps team, and the dictionary was a key of ownership tag, and then the value was the app role ID and secret. So get let's say the backend X app role ID and secret. We got that, and then step three, get secrets paths from policies. So we authenticate Vault with backend X Apple ID and secret, and then we get the Vault policies that are linked to the Apple ID of backend X. We parse the Vault policies and extract the paths of the secrets, because how do you set up Vault policies? You actually set up paths that has access to secrets. So we extracted the paths from the Vault policies that are linked to the app role of backend X. Step four, we get the secrets themselves. So we ask Vault, get us all the secrets from the paths that we extracted from step three. And then step five, we return the secrets to the secured operator of Airflow. We return it encoded dictionary, and that's that. This is the code. Again, I don't have much time to drill down further than that, but this is the overall and high level of the API service and the function itself. So we have step one is managed by these rows. So we expect to get the app name and app key through a header in the API call, and we get those and then pass them to authentication handler designated function to decide if this application is okay and we can proceed with the next operations. Step two, get Teams Vault creds. So if the status code of the authentication is 200, then we can proceed to get the team credentials, basically the ownership tag that we have, backend X. We pass it to this function to get the Apple ID and secret of backend X. If we were able to get it, basically backend X the team was set up in Vault, they were onboarded, we set up the key in the dictionary, all good. Then we get the Vault, we authenticate with the Apple ID and secret of backend X, get the Vault policies, extract the paths, and get the secrets of these paths. So this is done in these lines here. And then we return the secrets to the client. In our case, Airflow secured operator. And this is error handling. So if we weren't able to get the Teams Vault credentials for some reason, we return the error. If the client didn't provide auth headers, app name and app key, we return the error here. And if the client is not authorized to get secrets, we return 403 with this error. So the last component of the solution is Hashicorp Vault. Again, I'm not going to drill down too much, just mention and remind that secrets are kept in Teams hierarchy because, as you see, the secret service is built on top of that, is based on this logic. Ownership tag dictionary is managed by DevOps team, so whenever we onboard a new team to use Vault, we define it one time in this dictionary, and that's that. And SecOps manage Vault infrastructure, and the DevOps team, my team, manage department's namespace. So what did we achieve? First of all, we were able to align to security requirements and cross-infrastructure vision by leveraging Hashicorp Vault. So we were able to tap into the company vision and have one standard solution for all the use cases of secret management. Not all, but we started in this path. Standardized secrets management, so we avoid unclarity of data developers and data engineers. They don't know how to use secret and how to get secrets when they use Airflow, so we were able to eliminate that, define processes, and improve their velocity, and also set up a self-service for secrets management, because after an initial setup that we onboarded a new team to use Vault. That's it. They manage their own secrets. They can create new ones, delete ones, do whatever they want, and just utilize them through Airflow, and it is a self-service. And last but not least, because of how because of how the Secret Service is built, we were able to onboard more use cases to Secret Service. So we were able to consolidate tools, deprecate legacy implementations, and migrate them to Secret Service. So I know I didn't have much time to go over the whole bits and pieces and go more further than that. But if you have any questions about the logic, about the code itself, feel free to reach out through LinkedIn or email or Twitter, and I'll be happy to help. Thank you very much.